Hello everyone. For today, we're actually going to go backwards and we're going to review some material that is very, very important. We did it early in the year. It is solving with the distributive property. Now, I know some of us might remember the distributive property, some of us might not, so we're going to go over it again just so we have a better understanding. So our lesson goals are to apply the distributive property to solve one variable linear equations. Let me write that again. Linear, to verify and explain the steps in this process, and to use the distributive property to solve real-world problems. So the words to know. The first one is to verify, right? We should all know what it means to verify. It's to apply what is known to confirm an expected result, right? We want to make sure that what we're doing is true. To evaluate, to determine the value of, right? It kind of has the word value in it. Properties of equality. If we saw the combine like terms video, you guys should know that they are rules that allow you to balance, manipulate, and solve equations. And the distributive property is the property stating that the product of a factor times a given quantity containing a sum or difference is equal to the sum of the products of that factor times each addended within the quantity. Now that's a lot of words for something that's actually very simple to go over, so that's why we're going to go over it today. So here are the first examples. Here's our procedure, how to solve an equation using the distributive property. So the first step is to use the distributive property to remove the parentheses. Now remember, I told you guys that the distributive property, I'm going to write it up here in pink, right? It's going to be A, B plus C is the same thing as saying A times B plus A times C, right? I'm distributing this outside number to both factors on the inside. So negative 6 times 2x and negative 6 times, this is actually a negative 5, right? So if I were to go ahead and plug this in, actually the way they have it set up in this equation is it's just positive 5, right? Because they took out that negative. So the negative, I'm going to put it in purple. This negative is actually this one right here. Okay, so the negative is still there. They just didn't include it with the 5 on the inside, I guess, to make it a little bit easier. Right? But I can show you afterwards that even if we do it the other way, you'll still get the same answer. Okay, so we have our negative 6 times 2. So there's only one negative, so my negative stays. And then 6 times 2 is going to be 12. Right? Then I'm going to multiply negative 6 times 5, which again, only one negative. So it's going to be negative 30, and I'm going to move that. Remember, see how it's still, I'm going to follow this subtraction sign using the purple. Okay? That's going to give me minus negative 30 equals 6. Now, remember there's an invisible one right here. So that's really a negative times a negative, which is going to give me a positive. So now it's a plus 30, right? So that actually involves, now we are going to use the subtraction or addition property of equality to isolate the variable term. So it looks like they did a lot of steps to get from here to our actual step 2. And we'll say step, we'll call it 1 point, or 1b, right? So this would be like our 1a. So 1b, that step is combine like terms. Right? We wanted to do our multiplication. We wanted to get rid of our, sort out our plus and minus situation. So that was like our 1b. Now, the variable term is going to be the number that has the variable attached to it, right? In this case, it is our, let me put another color, our 12x, okay? So our 12x. Now, that means that this 30 needs to be moved out. So I have to use the subtraction or addition. So since this is a plus, I am going to subtract, right, the opposite of the addition to both sides. That leaves me with, remember, this is negative 30 plus, really, 6 minus 30, right? That's the way they want to say it, 6 minus 30. I keep the sign of my larger number, which is a negative, and then I can just do 30 minus 6, which is going to give me 24, right? I'd have to borrow. That becomes 10. 10 minus 6 is 4, and 2 minus 0 is just 2. So the 24. Now, I'm going to use the multiplication or division property of equality to isolate the variable. So this is a multiplication problem right here, this 12 and this x. So I'm going to actually divide it so that I can get that x by itself. So I divide by that whole negative 12. Remember, don't forget to do not leave that negative behind. Your answer will never be a negative variable, okay? It always has to be positive. So now I'm going to do the division here. I have a negative divided by a negative. 2 negatives will give me a positive. And then 24 divided by 12 is just 2. Okay? So that's it. Now if I were to do, remember what I said about this negative sign up here? Put a little star. So if I did my regular, right, distributive, that would have been negative 6, 2x. I would have just kept my plus, and it would have been negative 6 times negative 5. Well, that's still going to give me negative 12x. It's going to give me my plus, but now I'm getting rid of that negative negative, which is a positive, right? A negative times a negative is a positive, and then 6 times 5 is just 30. So it's the same step right here, just a little bit. I think to me it's a little simpler, but again, if it's easier to follow these steps that they give you, please follow those. Don't do my way just because it's my way. Okay, now the next step is identifying the steps. So use the steps to solve the equation. So the same thing we just did. So the first step is to, right, use the distributive property. So I'm going to multiply and multiply. And as we see, they skipped this step here where they broke it down. Right, that's the step where they broke everything down in the distributive property. They skip it here, right? They just went 4 times 5. Well, that's 20. And now I'm going to do 4 times 3, which is 12x, right? Now the next step is to isolate the variable term by adding 20 to both sides. So now I'm going to go ahead and I'm going to add my 20 to both sides. Right, this will give me 0. Now, I keep the sign of my larger number, which is 50. And then 50 minus 20 is just going to be 30. Okay? Now my next step is to use the addition. Oh, no, it shouldn't be the... Oh, okay, so it's using... I skipped ahead. So this actually matches these two steps together, right? These are the two steps we just did. That's why I got a little confused there. Right, I'm adding that 20. So that's my addition property. Now, I'm going to divide both sides by 12. That is my multiplication property. Actually, let me do it in a different color, right? Since our 30 is, let's do yellow. Oh, that doesn't work. Let's try a different color. We'll do green. So 12 divided by 12, and that's going to give me x equals negative 2.5. Okay, now if you do it in your calculator, you'll get that. Obviously 30 is not divisible by 12, so we'd get that. That's why we have it as a decimal. 30 there's only one negative sign, right? This is a positive. So the negative wins and the answer is a negative. Okay? And we're going to keep moving on. So the next one, verifying a solution. So look at the steps and at the solution. So again, first step, distributive property. I have my 10a minus 10 times 4, which is 40. Okay? Now, I use my inverse property of addition and add 40 to both sides, right? That gives me, so 0 plus 0 is 0. Let me work it out over here. 0, and then 9 plus 4 is 13, so 130, right? Now I use the inverse property of division and I divide both sides by 10. Now remember the trick that I told you guys, when you divide by 10, right? What you can do if this number has a 0 in the top, get rid of those zeros, right? That gives me what? 13 over 1, or just 13, right? You can do it in the calculator, but when it's something as simple as that, just cancel out the zeros. Now, you're going to verify the answer using a method called substitution, right? This is where you're just going to plug in your answer and see if it works out, right? So I'm going to replace my A with 13, right? That was my answer. So 13 minus 4 gives me 9. 10 times 9 is 90. So it works out. So it's a balanced equation. We know our solution is correct. Now it's very important to check that, especially when it comes to your negative signs, right? Because if you make a mistake and you put a positive somewhere, or you put a negative, let's say that we actually had 13, but it ended up being negative 13, right? This would have been what? 10, negative 13 minus 4. That would have been what? Negative 13 is the same as just adding, so negative 17, right? 13 plus 14, or 13 plus 4. That's going to give me 17 equals 90. That's going to give me what? Negative 170, 90. That is not true. This does not work. So it's very, very important that you pay attention to your negatives, because if you can make a simple mistake, right? It happens to everyone. So you need to check your solution. Always check your solution, okay? So the next one, we have a real world scenario. So I'm going to go ahead and grab my highlighter so I can make note of any numbers that we see. So it says, Janice is building a fence around a rectangular garden in her backyard. The area of the garden will be 240 square feet. The width of the garden is X feet shorter than its length, which is 20 feet. How many feet of fencing does Janice need? So, I'm going to go ahead. This one has a picture, right? It drew the picture for me. I don't really need the picture. So, our area, right? They're asking for the area. Remember that area is equal to length times width, right? Length times width. So it's telling me my length is 20. So my area equals, see, look at that already, length times width, right? Now it tells me my area is 240 square feet, so that's why the 240 is right on the outside. And then my length, which is 20 feet, right? You can see it in the picture there. It's nice and easy, right? And then I have my width, which is 20 minus x, right? So it's going to be that 20 comes from the length and however many feet short, right? The width of the garden is x feet shorter than its length. So now, they don't give me the steps, but we're going to write them out on the side. Step 1, distributive property. I'm just going to write distribute to save some time, right? I'm going to distribute. That gives me 240 is equal to 20 times 20, so I'm going to have 2 zeros. 2 times 2 is 4, minus 20x. I'm going to go ahead and add 20. Oh, actually, I'm going to. So this is an interesting case, right? Because I have here my negative 20x and the 400. I can either move everything around so that this becomes a positive, or I can just move this 400 over, right? So the step 2, use properties, I'm going to just say props of equality, and combine like terms. Okay, so that's step 2. So that's going to actually be 0. That's going to give me negative 20x equals. Now I'm going to keep the sign of my larger number, and then I'm just going to do 400 minus 240, right? 0 minus 0 is just 0. I have to borrow here, becomes 3, and this is now 10. 10 minus 4 is 6. 3 minus 2 is 1. So I have negative 160. Right? I'm going to go ahead and use my, let's go ahead and write step 3, which is use inverse operation, inverse op of the multiplication, or division, right? It depends on what we need here. So I'm going to divide both sides by 20. Remember that negative 20 needs to come along with it. So that's going to be x equals negative, and a negative is going to be a positive. Now I can get rid of my zeros, right? Because now 16 divided by 2 is a little bit easier for us. That's going to just be 8. And my last step, check your work. So now I'm going to go ahead, I'm going to pick my pink color, right? And I'm going to plug it in. I'm going to come up here actually. So my 240 equals 20 times 20 minus 8. So 240, 20, 20 minus 8, if I work it out down here, my workstation, that's going to be 12. And 12 times 20 is actually going to just equal 240, right? So that is my correct answer. So 8 works. This is my correct answer. And actually, here we have our fill-in. It's the exact same thing that we just did, so this should be easy for us, right? This is going to be 20 feet. We know our area is length times width. And we're going to go ahead, simplify and solve. Right, this is the same thing we did. They already did the distribution down here, and they carried it up over here. Right, 20 times 20, and then 20 times x, which is just 20x. If you want to put in the parentheses, we can. And that gives me the same thing we did, right? 400 minus 20x. I subtract 400 to both sides. I'm going to then divide by 20, negative 20, and it gives me x equals 8. Now they went back and they plug it in. 20 minus 8. Oh, and actually, you see, our question was, or it says just how many feet does she need. So the width of the garden is 12, right? We went over that too, right? When we did our checking our work. So now they go back and they go ahead and now they check their work. So they're going to plug in that x, they're going to plug it in with an 8. They're going to do the subtraction. It's going to be 20 times 10. I don't like the way they go in this order. That's why I'm drawing you guys these arrows, just because it's a little odd that they don't keep it next to each other when they have so much room at the bottom. So they move up here. We have 240 equals 20 times 12. And if you were to actually just do 12 times 2, you would get 24. Include that 0, and there you go. You can still see. Now, the other way to verify it is just multiply out the length and the width of the rectangle. So that would be 12 times 20, 240 equals 240. Now, how much fencing does Janice need? So, they actually now need the perimeter, right? So if you need the perimeter for all the sides, right, and they only give you the area, you have to do a little backwards. So our perimeter, and I'm going to write this in pink, our perimeter is equal to 2 times the length plus 2 times the width. Right? Because in our equation, actually in, any rectangle, you have 2 widths, right? And you have 2 lengths, right? So that's why it's multiplying by 2. So we have our 2 lengths plus 2 widths. So it would be 2 times 20, which again, I can just do 2 times 2, which is 4. And I have to include that 0, so 40. Plus 2 times 12, which we already figured out was 24. So 40 plus 24. I'm going to work it out on the side here so you guys see. 4, 6, 64. So Janice needs to go and buy 64 feet of fencing. That will cover the entire rectangle. Okay? And that's it for distributive property. So how do you solve linear equations using the distributive property? You can distribute the factor outside the parentheses to all terms inside. So remember, it's outside to inside. Then solve for the variable using equality properties, which are all things that we've already done before, all right? So if you have any questions, please let me know. You can reach out to me through Edmodo or Teams, Remind, whichever works best for you. And, I'll save any questions for our Zoom meetings, and stay safe and enjoy the rest of your day. Bye, guys.